Then I'll maximize this. And I will also, let's see, I guess I'll zoom. I think mostly I've been running in the zoom mode. So I'm going to use Community Assist. And we're going to do a couple of joins, okay? So most of you did in 220 a little bit of joins, like a tiny bit. You guys remember those? So I'm going to do just a real basic join. I'm going to do like person and employee. So just to show you beforehand, I'm going to select star from employee. When I do that, when we look at employee, right, it doesn't have the person, their name in there. It just has their person key. Mm-hmm. So what I'll do is I'll do a join between the employee and the person, just so we get their names in there. Generally, you want to see their names, not their number, right? So I'm going to, we'll do select, and I'll say person last name, person first name, I'm just going to break the line to keep that there. We'll do the employee hire date. I'm not sure I'll put in the, do we want their annual salary? We can. Employee annual salary. I think one of the changes I made in the newest version of this was to not put that there, put it elsewhere. All right, so notice one of the things that I've done in the select is I just list the fields. I don't care what table they're in. You do put them in the order you want to see them probably, but you don't care what table they're in. You just list all of the fields, right? All of the columns. Then you need to say what one of the tables at least is. So I'm going to do from person. All right, and then you can use the inner join. And we're going to inner join with employee. Okay, so that's the inner join syntax. And then you have to say how those two tables relate. By the way, inner is always optional. You never have to say the word inner. It assumes inner. So you could just say join, and it would work just fine. I usually do say inner, just to be clear, but then you have to say on, and I'm going to say that person dot person key is equal to employee dot person key. So I have to tell how those two tables relate. Primary key, foreign key, basically. The dot notation here, this is table name dot column name. You know, table name dot column name. You can actually query across databases if you want. We will eventually. If you do that, it would be database name dot owner, or basically dot schema name dot table name dot person name, or dot column name. Does that make sense? You can do a dot notation. You can query across databases, across servers, or whatever. This is called full notation. You don't have to do it if you didn't name the foreign key exactly the same as the first, as the primary key, but you have to distinguish them. When I run this, so you go down here, you'll notice that it shows the name of the employee hire date, and that. And it doesn't, an inner join only returns matching records. Does that make sense? It ignores anything that doesn't match between, in this case, between employee and person. So it only returns those persons that have a key in employee. That makes sense? That's clear?
So the first one is their IDs are the lowest ID.
Actually, it's just whatever order they're in the person table, or the employee table rather. It doesn't actually, I mean, we could put their person key in there also if we wanted to see it, or their employee key. But basically, it's just returning the employee table, but instead of the person key, it's returning these two things. All right, so I'm going to show you some variations of this, and then I'll show you how to do multiples. If you were working on an older, particularly older Oracle database, but if you're working on a different database, there's another syntax you can use, but I advise you not to if you can avoid it. But I just want you to know it exists. I will comment this as alternate, oops. It's also an older syntax. So the inner join is the ANSI standard, and pretty much every database supports it now, unless you're working on an older one, right? But a lot of older database administrators will still write things like this. So I'm going to do exactly the same for these. And then I'm going to do from person, comma, employee. Now you still have to say how things relate. So you have to do it as a where clause, where person.person key equals employee.person key. The reason why this isn't considered as good as syntax is it conflates the criteria with the relationship. Does that make sense? Where clauses are used to give you the criteria that you're searching for. So you're putting this in here, and it's giving you, instead of a criteria, you're using the where clause to show a relationship. It will give us exactly the same results, though. Some people prefer it because it's a little less wordy, but it has some dangers. If I were to forget the where clause, all right, so with the inner join syntax, if you forget the inner join and the on, it won't work, right? It just plain won't work. It'll throw errors. If I forget the where clause here, I get something else entirely. Okay, so notice we had, before we had, what was it, 5, 6 rows? Mm-hmm. Now we have 774 rows. And if you look at this, J. Anderson, actually, let's order it. Let's just do order by person last name, so you can see the effect a little clearer. All right, so notice that Paul Allen is in here 1, 2, 3, 4, 5, 6 times. He's mapped with every employee hire date, and he's mapped with every salary. What happens when you don't say what the relationship is you get what's called a cross join or a Cartesian joint. And basically what happens is that every row in the first table is matched with every single row in the second table. Right? It just keeps going. And notice, so it doesn't know which people belong. So we've got Anderson, we've got Baker, we've got Banner. A lot of these people are not employees. Everybody in the employee table is matched to every single record every single person in the person table is matched to every single record in the employee table. Okay. So basically everything in the first table, person, is matched to every single row of the second table.
Yeah, It's called a Cartesian.
It's called a Cartesian dump, Cartesian joint, or a cross joint. You can do this on purpose.
Why would you want to do that?
It's a good question. I've wondered that for a long time. I think that there are certain kinds of, particularly kind of matrix mathematics, where you want to see every possible combination of the data. I've also seen examples of, like, say you wanted to see, you were doing scheduling, and then you wanted to see every possible schedule combination, right? So it doesn't throw an error. The trouble with the old syntax is that this can happen by accident. And the only way you really know that it happened is that you got a whole lot more rows than you were expecting to get.
Yeah, that's why they had a new syntax.
Yes. And this has 774 rows because there isn't a lot of data. There's like 120 people and 6 employees or something like that.
But yeah, imagine.
Yeah, imagine if you had millions of records in each table. You could kill your machine. You could fill RAM. And your machine would freeze up. I mean, you have to be careful. But there, as I said, there are times you might want to do it on purpose. And the way that you would do it on purpose, I'm just going to copy this down, is that instead of just listing the tables here, you would do cross join employee. Well, not joint. Might be more fun, but cross join employee. What is it not? Oh, because I have a comma there. That comma needs to go away. Oops, not the end, the comma. This gives us exactly the same results as the other one did by accident. And if you look, 744 rows still. So cross joins are not illegal, but as I said, they're generally not something you want to have happen by accident, and their uses are kind of limited. I have never, the only reason I can think that it's called a Cartesian joint is Descartes must have said something about it mathematically, not about SQL or that, but about some kind of relationship. Okay, so let's do some multi-table joins. And generally, as I said, the old syntax is good to know, but I would always use the joins, and it's fairly easy. I'm going to do, I'm just going to real quickly do a select star from, what is it called? Those are Metro Alt-1 Community Assist. From, let's do from grant request. Just to show you what's in there. So when we do that, we've got a grant request key, which is just the key for the table. We got the grant request date. We've got the person key. We got the grant type key. And we got the explanation. And I think that's it. Is there anything? Yeah, so, and then there's the amount. Okay, so these are, there's several, these two at least are foreign keys that we might want to actually see the results. So again, what you want to do is you just want to see, so I'm going to say select grant request date. And do we want just their last name, person last name? I think it's grant type name. And I think I'll leave out the explanation, but I'll put the amount, grant type amount. I'm going to break these just so that they're easier on screen. Grant request amount. So this actually comes from 3 tables, right? The first table, let me move that down. The first table is grant request. Person last name comes from person. The grant type name comes from grant type. And then the grant request amount is also in grant request. So I'm going to do, which table you do first here doesn't matter, although as you get the hang of it, there's a certain sequence. If you think about the diagram, you're just trying to flow things through. You know, from grant request to person to grant type. So I am going to do grant request, and then I'll do inner join. And notice when I do grant request, those two, actually none of them are underlined right now, but those two went away anyway. I'm going to inner join it with person. And again, you have to say how they relate. So I'm going to say on person dot person key equals grant request dot person key. Now I still have, notice grant type name is still underlined because we haven't got that table. So I'm going to do inner join grant type on grant type dot grant type key is equal to grant request dot grant request key. Couple of things about this, especially as you go on multiple tables. You have to join like to like, right? You want to join person key to person key, grant type key to grant type key. I've seen people get weird results because they mix keys up. Right? If you mix the keys up, you may get a response because they're just integers. It won't complain, but your response is meaningless. It's just garbage, right? It's only if you're, usually only if you're asking for like to like. Person key to person key, you know, foreign key, primary key to foreign key, basically. When I do this, so I'll just do an F5 again. So we got their last name, we've got what they're asking for, and we got how much they're asking, right? So where this was just a key, now we know that what they're actually asking for.
Can you scroll over the code?
Sure.
Okay, so yeah, person dot person key, and it's grant request dot person key. But then
Yeah.
on line 38, you got
Grant dot grant type.
key, but then it's grant.
Oh, grant request key. That
Yeah.
may be, you're right. So this should actually, this is what you're not supposed to do. And what I did, I was wondering about that because there's actually a couple things there that shouldn't be there. This is better.
Yeah. Results.
Yeah.
Vary.
So actually, that's a good example of what happens if you get the wrong keys. That they don't match, but they're both integers, so it'll try to resolve them. Yeah, this is better. So, and that's an easy mistake to make, as I just made while I was talking. So, I want to show you one other variation of this, and then we'll actually do a couple things with it, and then we'll do outer joins. Joins may take a while to get the hang of, but they're not hard. And there's not a lot to talk about here. I won't have to go on for hours on it. Now, what I want to do is I want to show, I'm going to alias grant request as GR and person as P. And then I can do P.person key GR. And I'm going to alias this as GT. And I can do GT GR. So what it is it just lets you shorten things. What I would say about this, so GR now stands for grant request. P stands for person, GR, and you know, it just saves you some typing. I would say don't do this if it confuses you. Right? This will give us exactly the same results. Oh, I just hit F7 instead of F5. Let's go back here. F5. There we go. It gives us exactly the same results. It's just you can alias things to make it easier to type if you want. Here's a weird thing. I'm going to put grant request. What do I want to put up here? Something that was used in both. Let's do that for, say, for some reason you wanted their person key. That will give us an error. Anybody have a clue why? If you put a cursor over it, says ambiguous column name.
Because it's in multiple tables.
It's in multiple tables and it doesn't know which one to pull from. So you need to alias it. Or if I hadn't aliased it, I need to do person.person key. The reason I wanted to show this here is it does show a thing about SQL that you might not know, but can be important later. Notice I didn't alias this till down here. But I have to use the alias up here. It won't allow me to use person. If you have the alias, you can't use the table name. See, it underlines that. It won't allow it. I have to use the alias if I made an alias. What it tells you, actually, what does it tell you? You guys have any clue? Yeah.
Select section.
Right, so it doesn't, the thing, it isn't executed in the order you write it. It actually finds the tables first. So it does the froms, and then it will actually create a kind of a Cartesian joint underneath the scene, and then it will select the things from it that are valuable. But it does the select of the fields last. So despite the fact that you aliased it down here, you need the alias up here because this is actually not processed before it does this. It does the tables first and then that. It can matter. Things don't happen necessarily in the order you write them in SQL. They're passed off. Not that you need to worry about this, but they're passed off to basically C++ code, which then tears it apart, does all the processing, and then returns the result. So SQL is like it rides up on top of other programming languages, and it's not necessarily sequential in its processing. Does that make sense, sort of? I'm going to do one more thing with the inner join, and then we'll do the outer join. Any questions on this? Is this making sense? You're okay with it? It's not hard. It can be. It can take a while to get the hang of it, but it's not too hard. Especially if you stick to the inner join syntax. And again, inner is an optional keyword. You can leave it out. Join works. All right, so what I'm going to do is I'm going to do a little bit. We have, let's do like a a summary kind of thing. So I am going to do select year, grant request date. Do we want the month too? Let's just do year. Make it simple. And I'll alias that as year. And then I'm going to do grant type name. And then I'll do sum grant request amount. And I'll just call it total. Okay, so in this one, what we're doing, we're using the year function and we're using the sum function. I mean, things that we did before, we can still do, right?
Mm-hmm.
And typically, you're going to do inner joins for this. What this will give you is the total each year for each type of grant, right? Let's take a look at it. And we could get rid of the year if you wanted just to know the totals per type of grant. But I'm going to do from grant request, and I will alias it, although you don't have to. And then I'll do inner join. The only one we're bringing in is grant type. We still have to say how they relate on gr dot grant type key equals gt dot grant type key. And then I need to like group by, right? I need to group by year request date. And I need to request group by grant type name, because those are not part of the aggregate function, the sum. So let's see what we get. So there's in 215, there's each of the things, right, that it did in the totals for each one. 216 is out of order. So you could also order by the year. This is actually interesting. I think it will order this by the year by its alias. Let's get this down. So 216 should be at the end, and it is. Does that make sense, sort of? What I wanted to do show you is that you could do the inner joins and the aggregates and the functions, because typically when you're writing reports, you're doing a lot of this. You're writing inner joins to bring the data together, and you're adding the sums, and you're adding, you know, the things you're going to group by. So in 215, there were $3,400 with the dental request. 4,552 in education. You know, each one of these, that's the total for that year for that list. Questions on that one? It gets a little more complicated when you start adding functions, right? But you can do some neat things. You still have to group by, you still have to do the, you know. Okay with that? You guys are quiet. I don't know, is that good or bad or indifferent?
I got like a little different form.
What?
I got a different form. I got like childcare.
Where do you have child? Wait, it's out. Do I have childcare there?
Yeah, but mine. Oh, okay.
It just wasn't showing.
Oh, okay.
The thing with the Zoom is that
And it's frozen. The top thing is frozen.
Yeah. All right, so I think I'm going to let that be it for inner joins. Other than to let you know that sometimes there's no limit to the number of tables you can join. And there are times when you get really long strings of joining things together. What you know, the way you know what to join, do I have a diagram for community assist? So I do not have a diagram. You don't have to do this, but I'm just going to real quickly add all of these tables. And I'll close this. So when you see a table, like we were doing, what do we got down here? Grant request, grant type, right? You can see that there's a path. Grant type key is repeated here as grant type key. If we wanted to get to the reviews, we could go from grant request to grant review because grant request key is a foreign key in that.
Any place, so basically any place where there's a line. If there's a relationship, you can get to.
Right, and even if they're not directly, like if I wanted to know what employee, the position of the employee was, I could go, well actually, so I could go directly up to employee and employee position. If there's a path, you can write a query that will get you there. Does that make sense? As long as there's a relationship, you can work your way. You might have to work through several tables to get to that relationship. But you can't work through, you can do that. As long as there's a path, you can get there.
In order to see the path, you have to.
So it helps. I mean, you can sort of see primary key, foreign key by the names because I name them the same, but you could certainly create a diagram.
That's also why naming conventions are pretty important.
What?
Naming
conventions matter a lot, yeah, and I'm not great at it. Yeah.
I can't think of any good example right now, but if you needed to do a couple of different joints to get you from to link two different things together, but then you wanted to hide all the intermediates.
You don't have to list any columns from the intermediates. So, I mean, that's one way. You just don't list any columns from the intermediate tables.
You still join on.
You still have to join on them whether you have any columns listed to show or not. There are some dangers here. It is possible. So I don't know if you say foolishly added, you were looking at donors. I could do this if you want. And you foolishly listed the donors' addresses because some of the addresses have more than one. Right, so if I go to, let's see, where's donation? Donation is down here. It goes up to person. But if you list person address with a join, if a person has multiple addresses, their donation will also be listed multiple times. So if you were doing a summary on that, you could get a false value. Does that make sense? So you have to be careful what you include. Even if I didn't include the address, if somehow I included it in the joins, if somebody had two addresses, their donation would be listed twice. There are ways around that with like the distinct keyword and things, and you just don't include like the address if you're summing up donations. But it is possible. I just want you to know when you're joining tables, you can get ghost values if you're not careful. If one of the intermediate tables has multiples, it can multiply the values that you're trying to sum or average or something. We're not going to worry about that too much, but it can be a danger when you're doing things because you could come up with, as I said, false values. Okay, so there we are. I might do one in the example, but I won't do it right now. Let's talk about outer joins. Most of you have done some joins before. Does anybody know what an outer join is? So an inner join returns everything that's matched.
Everything that's not matched.
Well, it's not quite that clear, although it would be nice. What it does is it returns everything from one table, whether it has a match or not, and only the matching values from another table. So it is a way of finding unmatched or unused data. It's like it's a way of finding a customer that never made an order. It's a way of finding a product that's never been ordered, things like that.
It's a good way to find outliers.
Yeah, it's a good way to find outliers. So let's look. You notice we have these different grant types. Let's look for a grant type that has never been asked for, that nobody's ever asked for money for. There are a couple. I made sure that there were a couple. So when I do, I'm going to select grant type name, and then I'm going to select, and it's actually kind of important here. I am going to say, I'm going to alias these, but I'm going to do grant type name, and I'm going to do grant request, grant type key. Okay. From grant type, and I'll call that GT. The outer keyword is also, I think it's left outer join grant request, which I'll do as GR. You still have to say how these two relate on GT.grant type key equals GR.grant type key. All right. So we're going to run this and then we'll make a couple of modifications on it. Left outer join just means that we are going to return everything from the first table listed. The first table listed is the left table for whatever reason.
So it's on the left.
And then from the other table, the second table listed, we're only going to return the ones that match, that have like the inner join values. Where there is no match, so let's do F5. Whoa, let's do a distinct also. So when I run this, notice that there's a couple of these that have nulls. Right? And the reason they have nulls is that there is no matching key in the request table. So nobody has ever requested funerary or holiday money. Right? That's why these are null. There's not a null in the request table because, they're just not there. But in the results set, there's a null because they don't exist in the grant request. It was important to get that result, that the grant type key come from the grant request table, not from the grant type table. Does that make sense? Now, the way you could do this so that you only see the ones that are null is you just say where gr.grant request or grant type key is null. And then you would see only the ones that have no match. Right, and you could do something like that with customers that don't have a donation, right, or There are customers who never made a sale or purchased anything, items that were never purchased, things like that. The outer join is good for, particularly if you use that as null and have it right, for finding the things that aren't matched. Does that make sense? There is a right outer join. If I do a right outer join here, I'll get nothing. Unless I turn the tables around. So it's important to know which table you are searching. So I'm going to call, instead of from grant type, if I do grant request, and then do this as an right, and then do this as grant type, this will have the same results. So let's just do, but then I changed it to a route. I had to change which table came first. Right just means that the first table will only return the matching ones, and the second table will return all of the values. I never use right. I just don't think like that. It's always left going for me. Maybe if you learned it from Hebrew or some other language that goes right to left, it would make more sense to do that way.
That's for two tables. What you do for three or more.
So you can do with three or more, but it gets complicated. You have to think about the logic of what you're looking for.
So it sounds like it's not recommended.
Well, it can be. Typically, what you have is like one outer join, but multiple inner joins to get a, yeah. So you might inner join a result set and then do an outer join to see what parts were not part of that area, you know.
So it's like nesting there.
Yeah. You can do it. I mean, these can get really complicated. I'm not.
Typically, you do first two and then add another one.
Right.
Then add another one.
So I think one of the ones I have in the assignment does ask for like an inner join, and then just so you can read it better, and then an outer join to show you the.
Can we have the break now, or?
Sure, we can have a break, although I've only got one last thing to show you. Okay, so let's show the very last thing. This is almost exactly the same. Now let's go back up to the left join. I just want to show you there's such a thing as the full join. So I'm going to run it without, I'm going to make this full join. So what a full join does is it returns everything in both tables, whether they match or not. Right? So it shows the matches. I'm going to run it without the null. Notice it has exactly the same result. The only difference would be here is if there were, on the grant request, there were things that didn't match the other table as well. So there could be nulls over here if that were the case. But for this, I mean, basically a full join behaves exactly like a left join would do. So those are full joins. Full join just returns everything from both tables, whether they match or not. Whereas the left or the right only returns everything from one table and only the matching from the other. Yeah.
So would it make more sense to just do the full?
It depends on what you're looking for. It really does. If your table is well constructed, you should never have to worry about the nulls should only be on one side of that. If you have nulls on both sides, you got.
But then you got to, it's not twice, it's whatever, right? So
yeah, I suspect. Although I don't know, I suspect that the left and right joins are slightly. I don't know which one takes more time, more energy. Actually, that'd be an interesting one to know. Which is more efficient? But you can do both. I mean, most of the time, a full join will behave pretty much exactly the same as an outer join. I think that's all. There are. I'll just quickly say there are some other variations of joins that are a little bit weirder that we're not going to do them notice all of these have relationships where it's an equal. There are things where you can do greater than or less than. And but it's complicated and rare, and I think we will just focus on the basic joins at this point. So this is it. I will comment this a little and post it, and you can have a break, and then you can have the rest of the time to work on it. And I'll get you with the Metro Hall. We still have. Let me kill the video too.